lesson 7.5, we're going to learn about two special theorems that end up giving us some special proportions when we are working with triangles. The first of those two theorems is called the side splitter theorem. And the side splitter theorem requires a segment such as segment RS to be parallel to a third side of the triangle. In this case, it's parallel to segment XY. When we have these two parallel segments, those two segments divide the left and right sides of our triangles proportionally. In other words, I can compare the top left to the bottom left, and I will get the same ratio as if I compare the top right to the bottom right. The thing about writing your proportion is that you are consistent. This first ratio uses the left side of the triangle, and we are comparing the top left side to the bottom left side. Then we just switch sides of the triangle, and now we compare the top, but this is the top right, to the bottom, and again, the bottom right. If we take a look at number 1, first you want to notice these arrows. Those arrows are what guarantee that these lines are parallel. Because they're parallel, we can write the ratio that will compare the top piece to the bottom piece. From the left side, I would have 6 compared to 5. And from the right side, if I do top to bottom again, I will have 4 compared to x. When I cross multiply then, 6x will equal 20. And when I divide, x will be 20 over 6, which reduces to 10 to 3. So x equals 10/3. In number 2, once again, I take note of those arrows. Those arrows telling me that those segments are parallel allows me to write x to 6, which again is comparing the top of the left to the bottom of the left, and then x plus 1 to 9, top to bottom. To solve this, we will just cross multiply again. Be real careful, this 6 is going to have to be distributed to the binomial. So we'll have 9x equals 6x plus 6. When I subtract the 6x, I'll have 3x equals 6. And when I divide by 3, I get x to equal 2. That's the side splitter theorem. On the second page, you will see the corollary that follows. When you look at this diagram in the rectangle here, you don't see a triangle. What you should see are that there are 3 lines that have been drawn parallel. When you have 3 parallel lines, these transversals that intersect those 3 lines are divided in a way that those parts are also proportional. So basically, we're going to continue to compare the top part to the bottom part on the left side and set that ratio equal to the top part compared to the bottom part on the right side. In problem number 3, I notice I do have parallel segments, and that means my ratio of x to 5 will equal 3 to 6. Cross multiplying gives me 6x equals 15. When I divide by 6, I get 15/6, which of course can be reduced to 5/2. On number 4, I'm going to show you 2 ways to do it. If we continue to do the proportions where we compare the top to the bottom, the left side would give us 5 compared to 7, but the right side, we'd also need top to bottom. Top is clearly marked x, but the bottom piece right here is not known. Now, it is possible for us to put something there if we recognize that this entire length, in other words, the sum of these 2 parts is 15. Because that's 15 and the top piece is x, this can be represented as 15 minus x. And if you do that, then you can certainly proceed by cross multiplying and solving, and you'll be able to figure out x. However, some people struggle to get that 15 minus x, and so I'm going to show you another option. From the right side, I'm going to compare the top to the whole. And when I say whole, what I'm talking about is the sum of those two parts. The top piece is x, the whole thing is 15. And I can do the same thing on the left side. I just have to be consistent when I write these two ratios. So looking at the left side, the top piece here is marked 5, and the whole would represent all the way from here to here. Again, the sum of those two parts. That whole is 12. And then I can cross multiply. 12x equals 5 times 15, which is 75. Once I divide, I have 75 over 12, which then reduces to 25 to 4. And finally, on the last page, our last theorem is called the triangle angle bisector theorem. In this case, you must have a ray bisecting an angle. Bisecting an angle again means that these two pieces are both congruent. And the theorem says that when you have this angle bisector making these two angles congruent, it will divide the sides of the triangle. So the left side is going to be proportional, I guess, to the right side. There's multiple ways to write this proportion, but I once again like to use this proportion on the right. Segment AC is coming from the top of the left side, CD from the bottom of the left side. Then I switch to the right, and once again I compare the top to the bottom. So if I apply that in number 5, I take note that this segment is an angle bisector because these two smaller angles are marked congruent. From the left side of the angle bisector, then I can compare 5 to 4, and that will then equal the right side, x to 3. Cross multiplying that then, 4x equals 15, which means x equals 15 fourths. In number 6, once again, we do have an angle bisector. We know that because these two angles are marked congruent. From the left of the angle bisector, I would like to use 3 to x, 3 being more of the top piece, x being more of the bottom. But then when I switch and look at the right side of the triangle, the top piece would be the 5, and then this piece right here is the bottom on the right side of the angle bisector. Well, I can't get around it this time. I do have to represent that piece as something. Because the entire bottom of the triangle is 6 and the left side is x, that means that the right side is 6 minus x. So I'll put that 6 minus x down here, and then of course we'll cross multiply. And once again we have a monomial that needs to be distributed. So we'll have 5x equals 18 minus 3x. And then I add the 3x to both sides, so I have 8x equals 18. When I divide, x equals 18 over 8, which will reduce to 9 to 4. And that's the entire lesson 7-5. As you can see in your notes, there's an assignment that follows. That assignment is due on Monday.